Welcome all of you dears. This is the simplest and easiest way of teaching learning process in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra from Padmasri VK Patil Junior College, Pravaranagar. As long as 11 science is concerned, dear student, we are discussing the chapter Electromagnetic Waves and Communication System. And today is a lecture number 9, and in this lecture we want to discuss regarding ground wave propagation. So what is ground wave propagation, dear students? Ground wave propagation is a short range propagation. Ground wave propagation is a surface wave propagation. Ground wave propagation is useful for the communication over a shorter distance. For the ground wave propagation, the essential thing is that radio waves should have low frequency. Listen carefully. So what is ground wave propagation? So radio waves from the transmitting antenna propagate parallel along the surface of a ground so as to reach towards the receiving antenna. That I have written on the board. See here. In this propagation, radio waves from transmitting antenna, this is the transmitting antenna, these radio waves propagate parallel. Propagation is parallel along the ground or along the surface of earth so as to reach the receiving antenna. T stands for transmitting antenna and R stands for receiving antenna. That I have already told you that this ground wave propagation is useful for short range propagation, that I have written here. As soon as this wave propagate near the ground, a wave of opposite phase is induced by the ground as shown in the figure. See here, as soon as the wave is propagating, this radio wave is propagating near the ground like this, and they are transmitting towards the receiving antenna. Simultaneously, a wave of opposite phase, crest, here is trough, trough, here is crest, crest, here is trough. So wave of opposite phase is induced by the ground during the propagation of this wave of low frequency. Then what happens, dear student? Actually the wave is propagating near the ground, parallel to the ground, which are having low frequency. As long as the wave is propagating near the ground, a wave of opposite phase is induced by the ground automatically, and so that positive, negative, negative, positive, positive, negative, such a polarity neutralize with each other, and so that there is a net loss of energy during the propagation of radio waves which are propagate from the transmitting antenna towards receiving antenna. There is a loss of energy, and since there is a loss of energy during the propagation, this wave cannot propagate over a longer distance. This wave can able to propagate over a short distance, and so that we call it as short range propagation. And most important property of ground wave propagation is that propagating waves is of low frequency. Frequency should be low, that I have written here. Radio waves of low frequency is transmitted by this ground wave propagation. What happens when the frequency is large? This demonstration I have shown in the diagram. A wave is propagating of low frequency here. Here the propagation of wave is of higher frequency. So what happens here? If the frequency is higher, then plus minus, minus plus, plus minus, minus plus. That means combination of positive, negative, negative, positive increases. Combination increases. Coupling increases between positive and negative. Coupling of positive polarity of propagating wave and negative polarity of induced wave. Coupling of negative polarity of propagating wave and positive polarity of induced wave increases, and in this way this combination increases. Energy loss is high when the frequency of propagating wave is high, and if the energy is high, if the loss of energy is high, loss of energy is high, and so that such a wave cannot propagate satisfactorily. They can't transmit up to the receiver if the frequency of the radio wave is high. So for the ground wave propagation, frequency of the radio wave is as small as possible for the satisfactory propagation, because if the frequency is low, then loss of energy during the propagation is low, and such a wave can satisfactorily transmitted because energy loss is less when the frequency is low. Here the frequency is high, so loss of energy is high, and such a wave can't transmitted during the ground wave propagation. But there is another one important advantage of low frequency. Since the radio wave propagation is of low frequency, it can easily, comfortably bend around the obstruction. Suppose the obstruction is there in the path between transmitter and receiver. This obstruction is nothing but the disturbance. If the disturbance arises in the path between propagating wave, then if the frequency is low, then it can easily cross. If the frequency is low, the wavelength is larger, and if the wavelength is larger, it can easily cross around the obstruction. Though there is a obstruction, though there is a disturbance in the path of propagating wave, then if the frequency is low, then it can easily cross, it can easily bend around the obstruction so as to reach the receiving antenna. And that I have already told you that this ground wave propagation is very useful for our local broadcasting only. This ground wave propagation cannot be used for the communication of longer distance. So the uses of ground wave propagation is, it can be used for CCTV, closed circuit TV. It can be used for CCTV. For local broadcasting, it can be used to submerge the submarine into sea. To submerge the submarine. To submerge the submarine means what? It is nothing but a pan budi. To identify the submarine in the sea level, this ground wave propagation is very useful. So this is one of the most important example of ground wave propagation. Closed circuit television, wireless communication in the police department. Within a shorter distance, by making use of this ground wave propagation, there is a convenient communication, possible communication in between police to police during a short range distance. This ground wave propagation is useful. Only the disadvantage of ground wave propagation is that since this wave propagate near the ground, a wave of opposite phase is induced by the ground as shown in the figure like this, and because of such a wave of opposite phase is induced by the ground, there is a loss of energy. There is a loss of energy. And since there is a loss of energy, such a wave cannot propagate over a longer distance. This is called as ground wave propagation. But this ground wave propagation is the most important, most useful, most convenient propagation for the local broadcasting, dear student. So listen this article again and again, read this board again and again, take a screenshot and write a note in your notebook, dear student. And in this way, we have discussed today ground wave propagation. In the next article, we see space wave propagation and sky wave propagation. Goodbye.